Hi everyone, I'm Zhengtian, and I'll be talking about my final year project, which is a full-stack mobile application for 3D modeling. A little bit background on 3D modeling. It is the process of developing a mathematical coordinate-based representation of any surface of an object or scenery in a three-dimensional space via specialized software based on edges, vertices, and polygons in a simulated 3D space. There are many ways to generate 3D models, such as through deep learning, where we use 3D generative adversarial networks to generate the model, or we can call upon 3D artists and 3D modelers to draw the 3D model by hand, and also 3D modeling via depth sensors such as LiDAR sensors and true depth sensors available on modern smartphones. And lastly is a technique which we'll be focusing on today, which is called photogrammetry. A little bit background on the modern use cases for 3D modeling, where it is gaining huge popularity, such as 3D printing, 3D arts, we can think about NFTs, and also the metaverse, which has exploded in popularity, where all objects and sceneries in the metaverse has to be represented in 3D. A little bit background on the photogrammetry technique that we mentioned earlier. It creates a model using algorithms to understand the shape and textures of real-world objects based on 2D photographs taken from different angles of an object, as shown in the picture here. Some advantages of photogrammetry is that it is simple and fast with low barrier to entry, where it only requires a 2D camera to take the 2D images, whereas compared to having extensive 3D hardware such as LiDAR and true depth sensors, which are often very expensive. Another advantage is that it does not require large 3D data set, and is able to model any type of objects and environment, which is a problem faced in many neural network models. However, photogrammetry does have some advantages, such as it may require multiple images to construct 3D model, and the precision and accuracy depends on the input images quality and the number of input images. A quick run through of the project objective is to actually build a cross-platform compatible mobile application to take 2D images and also to be able to display 3D models. Lastly, also a backend server will be built to receive images and conduct photogrammetry to return the 3D model. A quick run through of the system architecture of the whole project. For the front-end app, it will be built in Flutter to enable the cross-platform compatibility, where its main purpose is to actually take images and send it back to the backend server. Once the backend server receives the images, you will pass these images into a photogrammetry pipeline, where you will process the images and generate the 3D object files, which contains the 3D object itself in an OBJ format, and it also contains the texture files and the different details of the object. It will all be zipped in the 3D object and send it back to the front-end app, which will be stored in the application storage. Users can then load the image and then load the object and view the object and interact with the 3D object in real time. So here I'll now go through a demo of both the front end and the back end concurrently. So in the app, first, we will select the images that we want to upload from our gallery. So I've pre-taken 20 images to be uploaded of a shoe object. So once done, the images will both be displayed on our phone for us to view. We can then send the images to the backend or remove the images. So after the image has been sent, all these images will be put into the input folder in the backend. After that, we can run the command to run the photogrammetry pipeline. For this, it roughly takes about 10 minutes for 20 photos. So here, you will start running. So once the processing has been finished, we can now download our object from the server. For the object just now, it took about 8 minutes to generate. So if you click on the download object button, you can see that the download begins with the current date and the timestamp. After that, we can extract it, and the file will be extracted. And then we can go to our list of 3D objects and view the most recent one. You can see that this was the shoe model that we have taken. We can also interact with it and zoom in. So we can also view a list of other previous models that were generated, which will be saved on the device memory. And lastly, the optional step is to clear the server, and then you can see that all the output and input will be cleared. Thank you for viewing my project, and I'd also like to have a special shout out to my supervisor, Prof. Tian Ke Mao, for his guidance and supervision throughout the whole project.